Okay, let me share my screen. Okay, cool. Let's get started. Welcome everyone to this week's ChainSync. Let's first get the update from people on what their progress was for the last week. Okay, let's start with Michael again as usual.
All right, thanks, Bob. So I've still been working on the 8-shard network. I still don't have it stable, especially under transaction load. The investigation that I'm starting to look at now is around routed messages. So one thing that I've noticed is it seems like blocks propagate through the network much faster
Yep.
than chunks do.
Yep. Well, that's actually quite expected because we broadcast blocks, and for chunks we don't, and
exactly, yeah, they're routed to individual places instead of just being broadcast. Yeah. And so what ends up happening is a node will, a lot of the time, get a block before it gets its chunk part, and so it won't.
Yep.
Eventually gets the chunk and then adds the block, and then is able to move forward. And this latency seems to be causing problems. And the forwarding mechanism doesn't seem to actually help very much because it's routed. Yeah, it's interesting. But what I'm observing is that when I turn off chunk requests, right, the network actually performs worse than without chunk requests. And I think the reason is because if you get a block with a chunk you don't know, you go ask your peer for it. And I think getting it from the peer is faster than, or at least sometimes anyways, is faster than receiving this routed forwarded message.
I see.
So I'm trying to dig into that a little bit more deeply. I've added some logging so that I can keep better track of how many hops on average routed messages are taking and roughly what their latency is and that sort of thing.
Yeah. Actually, I think, well, unfortunate that Marcelo is not here. I think Marcelo has done some investigation before regarding this, and maybe we can you can talk to him, or we can discuss it together. I think so. We have in this experiment we have about 100 nodes in the network, right?
Yeah, there's 108 nodes, 100 validators, 8 RPC.
Yeah, I think the diameter there should just be 2. But you're right. I mean, even 2 hops is sometimes can take 400, 500 milliseconds to finish. And it's although it's interesting that the forwarding doesn't really help that much. It seems.
Well, it's not that it doesn't help. Yeah, it does help. Definitely when it's off, the system works much worse than when it's on. But it doesn't help enough is I guess what I should say, because the network is still losing validators for not enough chunks. So what I'm wondering is whether or not there's a way to make this forwarding mechanism more efficient, or maybe just the routing mechanism in general more efficient.
Yeah, I don't. So I think the forwarding itself is almost as good as it can be, right? I don't see how you make it even better. It seems that the latency is in the delivery of the message, not how the messages are sent, right? They are directly sent to the guy who's supposed to receive it.
Well, they're routed to the guy who's supposed to receive it.
But sure.
At a high level, yes, they're directly sent. Yeah.
Yes. So I don't. Yeah. From that perspective, I don't think you can improve much, right? But I think the devil is in the details, like how. Yeah, as you said, right, it can take multiple hops, and that's that could be where it gets slow. And we can of course, do more investigation of that. I also remember you said something that you want to. You said something to me yesterday about you want to comment out some parts of the code and see how it works. Is that?
Yeah. So I commented out basically the part that was asking for chunks, like the chunk request code. I see. Which is how I was investigating this. How do this forwarding versus request, which sort of leads me to believe that at least more than half of the time the block arrives, there's a request sent out and a response is received before the forward arrives, which is interesting.
So basically what happens is that for some blocks, there are some validators who receive the block, but it takes them a quite long time to fetch the chunks, and therefore they apply the block too slowly, and therefore the chunk they produce does not get included. So basically the bottleneck is in the kind of applying or rather getting enough data to apply the block.
Yes, that's what I think is the case.
I see. Okay, so there basically is not really a bottleneck in kind of the processing of either chunk parts or applying blocks or other parts of this process.
Not that I can tell, at least not in like the traditional sense of we're burning a bunch of CPU cycles where we don't need to or something like this. I think there is some subtlety here. So for example, the way the routed message code works, we have to totally deserialize and reserialize the message to route it, right? So it gets sent to some node, that node totally deserializes it, realizes it's not for them, reserializes it and sends it along, right? So that is some unnecessary processing potentially. If we could catch sooner that this is a routed message that it's not for us, maybe we could get some wins there. But I'm still thinking about what's possible and what's worthwhile and so on.
Yeah, but we do verify so for those messages we do verify signatures, or do we?
I'll have to double check. I'm not sure off the top of my head.
Okay, sure. Yeah. Okay, that sounds good. Yeah, we definitely need to investigate more there. But it seems like we already have the general direction, and yeah. Yeah, and I think this not only applies to multiple shards, right? The same process is still the same in the single shard case.
I think part of the reason why forwarding helps a lot in the single shard case is because every node is tracking the shard. So so forwarding basically means that you end up getting to reconstruct the chunk faster, right? You have to send out fewer requests. But then in the 8 shard case, that's not true. So for nodes where they get a chunk for a shard they don't track, just a single request response is all they need to be good to go. And that's the same as getting like a single forward is all they would need to be good to go. But
yeah, that's true. Okay, that sounds good. Let's discuss more maybe offline.
Sounds good.
Okay, Piotr, what's on your side?
Yeah, so I've been working for them most of the week on fixing the security issue. So I fixed the first part of the issue, and now at least all the nodes will no longer crash. And I'm not sure, is this recorded?
Yeah, I mean, it's fine. The fix is already.
So I found out a new security issue, but I'm not sure if I can discuss it here.
Yeah, let's not discuss that here. But yeah, I mean, you can talk about the one we already fixed because it's already
the one that
validator on mainnet already adopted the fix.
So did we publish the details of the issue that was already fixed?
Not yet. Yeah, I think we are blocked on the process of publishing it.
And I'm not sure.
But the thing is that the fix has already been adopted. But publishing this is a separate process, which I believe it's not really an established process. So we're trying to figure out there. But it's not really blocked. That and now it doesn't really contain like very sensitive information. In a sense, because validator already adopted the fix.
I see. So it's fine if I talk about it then?
Yes.
Yeah, so basically the fix that so there was basically the type of attack where if you create a huge number of connections, you keep creating them, we would create a new thread for each connection that gets open, and that would cause out of memory issues. So I did a fix that should prevent us from going out of the memory. I added also a test for that, and also analyzed like all the potential implications of that fix. Also work on making the changes to detect, to figure out where the memory leaks are, but I didn't have time to. I just started yesterday the node with the changes, so hopefully in a couple of days we'll see how the memory is growing and where the leaks are. And also I'm going to write a document that describes how you can improve like the compilation time. I was able to improve like the compilation time on my desktop from 8 minutes to 1 minute and 20 seconds.
Oh, so that's very impressive.
So I figured out a couple of more things that I mentioned before in the chat. I will write a document that describes it. I also figured out how you can do it without changing the cargo.toml. So that way I don't have to change the cargo.toml for every branch. That's more comfortable to use. And
yep.
You can also get it to work with IntelliJ, but it might require to do a hack, but I will describe it. I was talking, and in the future we are going. Basically, the issue with IntelliJ is that there is no way to pass the environment variables right now to Cargo, and you have to do a hack. And
I thought there is. Oh, maybe I was wrong. Yeah, I think I tried a very long time ago.
I mean,
don't really remember the details.
I mean, I investigated the environment that which gets created when you start the Cargo, and I checked that none of the variables that you actually pass, that you can specify in the settings, get actually passed in there. So as a workaround, what I had to do is create a bash script that replaces the Cargo binary and set the variables there, and that helps with
I see.
With getting the Cargo to work with the CLion.
I see.
So unfortunately, that's the only way I see right now, unless you want to modify cargo.tom.
I see. Yeah. Okay. So
better. So if it takes like 5 times less time, and I will write a document that describes it, how to do it.
Yeah. So my question is like the way you improve the compilation speed. Does it have any impact on the performance, or does it omit some optimization, or is it like pretty much the same?
I mean, it also depends like which optimizations you want to use. If you disable building the symbols, I mean, if you basically you can improve the performance with the compilation time without affecting the performance, but then you get a slightly higher compilation time. So it might take, let's say, 2 minutes. instead of the 8, and I basically specify what you can do.
I see. Basically, yeah, I think I know if you remove the link time optimization, it will improve the completion.
One thing is the link time optimization that you can remove. It should not have that huge performance, but the other thing that I did is you can use, for example, a different linker. Instead, by default, Rust uses the LD linker, which is slower than LLD linker, but then you also have to install it manually. So on Linux, you can easily install it, but on Mac, you would have to build it yourself.
I see.
And there are also some other flags, like there is a flag that basically, there's an experimental flag for the common generics, which basically causes that if you have a few generics in different, for example, in different packages, they will not be compiled separately. You would use the same code, reuse the same code, and that improves the completion time. Of course, it's an experimental feature, so it's not guaranteed to work, but I didn't have issues with it. But it also improves time a lot.
Okay.
And there are also a couple of other things. There is also a tool called SCCache that can cache all the compilations of the libraries. And let's say if you, so the way it works, that it basically runs a service on your machine that stores in a file the compiled version of the libraries. And if you need to recompile something on a different branch in different folders, it will reuse the cache of compiled libraries you had before. So it's, even if you do cargo clean, it will still reuse the code that was already compiled in case you compile the same library that was not.
I see.
So it's there are just there are a couple of other options. I will write a documentation and just show in how much each option helps, and then you should decide because sometimes you might not want to run. Sometimes you don't need the debug symbols, and you are fine compiling without them. And sometimes you want to compile with them. I mean, the difference is not that huge, but if you really want to save a couple extra seconds, you can compile without the debug symbols.
Right. Yeah. Okay. That's great. Yeah. Thanks a lot for doing this work. I think it will help a lot of people.
Yes, and also if you actually want to run the binary in the release mode, which you probably have to, because it would be too slow otherwise, you can actually specify the level of inlining. You can specify the level of inlining to be at 25, which is basically enough to still run the binary, but the inlining will be not as aggressive, so you still see like reasonable stack traces.
I see. That's interesting. Yeah.
So that helped me for debugging, and I will also include this information that you can do that, so you can still have like some reasonable debugging even in the release mode. But of course, some things will be inlined just because Rust is creating a lot of abstractions for almost everything. And if you wanted actually execute the code the way it's written, you would have to jump to a function just to execute one instruction, to jump another function to include just execute one instruction. And that's why in the debug mode is like 10 times slower, because like iterator will do a lot of things in the debug mode, but with the slight optimizations, it should work still mostly fine.
I see.
Anyway, I have some, basically I will in the document include like 3 ways of running the binary. One is without any optimizations and without any debug code. Another one which is like like a balance where you still have it. And so you still have, let's say, you still can run the binary in debug in the release mode, but with the right symbols. And another one, if you just want to run a release mode. So it depends on your use case, like how you want to run it, because it depends on what you actually want to do.
Sure. Yeah, that sounds great. As I said, yeah, it will help. I think not only internal team members but also external contributors.
I also noticed that the Google machines in the Google Cloud, they are really slow. So like even 8-core machine is,
right.
Let's say, takes around 20 minutes to compile the code versus without optimizations versus, let's say, 8 minutes on my machine, which is also has 8 cores without threads. So it's around 2 point. So basically, it's like 2.5 times faster just by itself.
I see.
So it's, I mean, probably it's also possible to even improve get the compile time probably less than 30 seconds total one if you had the top processor like 3950X, which is right now one of the mainstreams you can get. So that will take even less time.
Okay, good. Sounds good. Thanks for the work. And yeah, let's get to Misha. Misha, are you here?
I'm here.
Okay, yeah. What's on your side?
Yeah, so I pushed that chunk mask fix.
And
yeah.
And I think you pushed it last week, right? Oh yeah, I think we already
pushed it last week. And then I also was investigating the potential deadlock.
That's interesting. Like sure. I mean, there is a possibility that it is a deadlock, but it's also possible it's something else. So did you actually find any evidence that it could be a deadlock?
All I did was went through all logs we have in our code. Doesn't seem like any of those could be.
Yeah. That's I kind of did the same thing as well. I don't think. So basically, there's only 2 logs that are kind of even shared between the thread. One is the log inside the try for the caches, and another one is the cache on Epoch. It's a log on Epoch Manager. I don't think there's a single place that we even take those 2 logs at the same time, let alone like in different order. So
yeah,
I at least I don't see the possibility of us deadlocking inside our own code. I mean, yeah, I'm glad that you verified it as well. Because you're actually more familiar with the code on the try. But yeah, as I said, I don't think it's possible to deadlock within our code. Maybe in some dependencies, I'm not sure.
It's very suspicious.
Yeah, actually, Peter, you might know this better. Does Actix actually have any logs?
Well, there are some logs. Well, technically, yes, Actix has some logs. It depends, for example, on how you initialize the queue. By default, the queue will have a size 8, and if a queue is full, then you would basically, the thread that tries to add something to a queue will get locked. But it also depends on how we use it. So sometimes you can also add elements in queues in 2 ways. You can add an element to a queue in a blocking way, where you, if the queue is full, then you wait for it, and you can also do it in non-blocking way. So it depends.
Yeah, I think we always use the non-blocking way. I don't think we ever use the blocking way to add to the queue.
Right, but what happens if queue is at capacity?
I mean, this queue technically doesn't not have like an upper capacity, but you have a counter, and it's up to the person that decides where to put something to a queue whenever it wants to lock. So you don't increase the capacity over 8, but it's implemented basically as a list. So it's technically it can be any size.
I see. Yeah, I mean, Yeah, actually, for external dependencies, I'm not even sure what's the best way to to investigate this.
I mean, do you actually see some kind of locking happening ever?
Yeah, that's the problem, right? So we first need a way to detect. So what I've seen is that people report that their node gets kind of stuck, like it get completely stuck.
I mean, I could, for example, provide you the right flags, how to compile the binary, so at least you get the reasonable output. And then you could, for example, if you see that the node gets stuck, you should be able to start GDB and print stack traces of all threads to determine if they are stuck or not. And if they are, there should be at least one thread that is waiting in some line on some log, if that's actually happening. But it's also possible that your machine might be slow enough, and or something else happened, and because we don't really have I don't really see anywhere like good performance statistics. So I could add like some performance statistics. I will work on adding some performance statistics. At least you can tell if. At least it would be good to tell which. You should be able to tell which actor is stuck. So I should be able to print like per actor information per actor, how much it is using, and if you see it's not printing anything, then you would know it's stuck. So, but I mean, it's not a universal method, but anyway, those are like the two methods that I would use right now. Just one is just instruct people to compile in a specific way, and then run GDB. And
yeah, can you maybe also add that to the documentation or to the README as well? I think that could also be helpful.
Yes, I can make a separate section on.
Sure. Yeah.
I will have to check exactly how to get information for all the threads, but it should be straightforward. Documented, and then if people can see, then we would at least know something.
Sure. Yeah, that sounds good.
Separately adding also a branch or like some extra flag, which causes, let's say, the performance statistics be printed would also be useful for those people, because then you would then we would at least know if it's like if one of the actors is blocked, which could happen, or if it's something else, then we'll
Okay, yeah, let's okay, yeah, we can definitely follow up with this offline. Yeah, Michelle, what else other than the deadlocks?
Yeah, and I'm still continuing on orphans and one state part.
And how is that going? Are mostly focusing on the fix for the orphan pool or the state part?
Orphans for now.
Okay. Yeah, when I understand it's not a completely trivial change, so I assume you're now adding the signature verification for approvals as well, right? Okay. So do you have like maybe an ETA on that?
This one shouldn't take too long.
Okay. Is that a week or?
Yeah.
Okay. Yeah. Okay. Sounds good. Yeah, I assume that's okay. Yeah, we can also check in next week to see the progress. Yeah, and I think the update on my side, I was mostly dealing with critical issues on mainnet. This includes asking people to fix it, or first investigate and ask people to fix it, and also communicate the fix to the validators, and also yeah, merge the fix back to near core when validators have upgraded. And now the final missing pieces, we need to figure out process for publishing those security advisory issues. And yeah, I mean, last week is kind of a stress test on process. I think it definitely has some room for improvement, but I also was glad that it all worked okay. We were able to push some fix, which one of them is even a protocol change very fast. So yeah, that was overall I'd say like a not too bad of an experience. Okay. Does anyone want to discuss anything else? Okay, I assume no. Okay, sounds good. Let's end it here and see you guys next week.